Welcome to another screencast where I'll analyze some data in R without seeing the data in advance. So as usual, this dataset comes from Tidy Tuesday. That's a weekly data project from the R for Data Science online learning community. Every week they release a new dataset, and many people do analyses of it, and including me, and I'm making a screencast out of it. This week we're going to be taking a look at space launches. All right, so I'm excited about this. When I was a kid, I was definitely interested in space. Went to space camp. I'm looking forward to seeing what we can find from this data. All right, the article looks like the space race is dominated by new contenders. I guess we're going to be looking at some launches into space over time. All right. I generally don't look at the article before I do the analysis, so we're going to be taking a look at these two files, launches and agencies. All right, anytime I see two files, I think this is a form of tidy data. We have one row for every launch, and then you have your link to the launching agency from the between these two tables. It's actually, most of the data sets I've seen, they don't have two separate data sets, so this is going to be a little bit different than some of the other approaches. What I'm going to do is grab the URL for each of these data sets. I then open up a new RMD in RStudio, and I read it in. So I say, let's say library tidyverse, agencies is read CSV from here, and then I'm also going to include launches. Here's the link. Here's the launch data. Okay. Oh, I didn't take the raw version. Here we go. The trick is that I need to be looking at this version where it's just directly the raw data. Let's see if that one worked. All right. So we have 5,726 launches. And here we go. We have agents. And how many agencies do they come from? 74. All right. Some include like NASA. Makes sense to me. From here, it looks like we also have ones that are listed as US. Okay. So let's take a look. I'm going to look at the launch data first. All right. So we have a tag. I'm going to take a look at the glossary. I've been really excited. They always provide one of these code books. So we have a tag. We have a date. Good. It's it's in the format I would most want it to be in to understand it. For R to understand it. And it's able to parse it as a date. We have the year, the type. It looks like the type of launch vehicle, type and variant. Mission, it looks like just a term describing the mission. I'm going to guess, I'm not 100% sure about this. I'd have assumed some of them to say like Apollo or something like that, but I actually don't say Apollo among these launches. I'm assuming they're sorted. No, they're not quite sorted. Here we go. All right, yeah, this is a way of showing that we're showing the first one being Sputnik, and then we're moving on to, so I know that I need to sort the data first. I would expect in the 60s, I'm trying to remember what I know about the space program, to start seeing like Mercury. I'm not quite seeing that. Here would be an example of a Mercury mission launched by NASA. Okay, I'm just trying to get a feel for like what the individual columns mean and how I compare them to my own understanding. So, for example, can I find in 1969? Can we find Apollo 11 that went to the moon? I'm moving forward to 1969. Let me see. Type Saturn V, Apollo, CM107. I'll try this another way. Let me try filtering. String detect mission Apollo. And look at me misspelling Apollo. Here we go. And I'll arrange by date. Oops. Arrange by launch date. Okay. What it's looking like is these might be descriptions that are these might be slightly different codings than we're used to, like Apollo. We're accustomed to Apollo 13, Apollo 11 as being space flights. But I wonder if I Google Apollo CM 114. Looks like that was also known as Apollo 17, I think. All right, so that's a good thing to know. Just if I'm trying to figure out what each of these columns mean. I'm going to take a guess that this is Apollo 11. I don't know too much about it. No, that looks like that was Apollo 10. Maybe. So Apollo 11 was the first mission to the moon. Yes, it looks like. It's a little bit hard to understand. Here it is. Apollo 11 looks like Apollo CM 107. Okay, all right. So I'm learning a little bit about some of these columns. Okay, I like to put the reason I'm looking at that is I like to put this data in context of what I understand. Similarly, recently we see a mix of state, private, and startup. So I'm guessing early on it's going to be almost entirely state, and later changes to private and startup as well. We're going to confirm that in a moment. In fact, let's confirm it now. So I'm looking at launches, and I can try counting by both launch year and agency type. And then I can make a graph where I say, let's look at launch year N color equals agency type. And I'm going to guess there's only 3 types, but maybe there are more. Yeah, private, startup, state, 3 types. That's a pretty solid graph. In terms of understanding, there used to be loads of state launches. I'm going to quickly set theme light for my ggplot2 theme. And there used to be loads of launches. Let's say y is number of these. How would I do I describe these launches? I'll say launches per year. Yeah. Year, and I'll say color equals agency type. X is, you can say time. So it looks like there used to be more than 100 launches a year from state actors. This declined, and then we saw private show up, and then we saw startups entering. All right, so that's a good start to understanding this data. All right, and let's see. I wonder what agencies show up the most in terms of number of launches. I'm going to say count agency sort equals true. All right, lots are missing. It looks to me like agency might only be counted for state agencies. So I can say agency type. So it looks like, no, I'm wrong about that. It looks like private can be, for example, AE. So these are codes, which means I probably need to join the data. I need to say agencies, agency. I'm going to take a look at the agency data. 74 agencies. This is probably the count of number of launches. Time. I'm guessing time when it started, when it ended. Wonder what class means. A, B, C, D, B, C, D. I don't know what it means. This would be presumably Soviet Union. So Soviet Union had more than 1,500 launches. Type of org, class of org. These aren't that helpful. Like I don't know type OLA. I don't know what these mean. They're not really in the code book. Doesn't give me a sense of what that column means. So it looks like we've got our agency. This is what we're joining on. And I've got a short name and we've got a long name. So this would be helpful in terms of, here we go. RVSN would be the description of, this would be the description of the agency in terms of the USSR Space Force. This looks like another Russian Space Force. That's why we have a state code of SU. So if we were looking at governments, it looks like we would be able to say, there's agency type. If we're looking at government, we'd be able to say here's the U.S. Air Force, here's NASA. And if I'm going down the list, here's SpaceX, a private company run by Elon Musk. Boeing, Lockheed Martin. We're seeing more of these this mix of startups and public agencies. So what we could do, let me see. English. See, I'm trying to figure out what would be the canonical name we'd want to use. Because I'd like to use. All right, I'd rather use strategic rocket force, but I'd really rather look at country. All right, so this is the thing. If I wanted to look, let's say I wanted to compare state agencies, what I'd want to do is look at let's start by looking at state codes. So if I say agencies, count state code, I'm going to weight by the existing count that is the number of launches. So I'm going to say how many launches did each state have. Soviet Union and Russia lead it, followed by the Soviet Union and the United States lead, followed by Russia since the breakup of the Soviet Union. CN stands for China. I'm gonna guess F means let me add agency type. I was gonna guess F means private. Oh no, you have private U.S. I wonder what F and J mean as state code. So here, let's see, state code, responsible state. Well, what shows up as F? State code equals F. 3 areas. Let me see. 3 agencies. AE. These are France. It's frustrating to me that it's just F. Generally, I would have expected FR to be the ISO 2-letter code for France, and that means I'm going to guess J is Japan. So I'm going to take a look at that. Yes, it looks like J represents Japan. That's certainly frustrating. Here we go. I'm going to go back to the count. So it looks like we include private as being, and startups as still representing one particular company. Here's France. Again, IL, I believe, is Israel. And IESA. What's IESA? State code equals ISA. Some data quality steps where we're examining this. Okay, it looks like, so it's launched in Paris, but it looks like European Space Agency. Okay, I'm going to guess that means, in some sense, so it's European Space Agency, so it's multiple countries, not one particular country that's responsible. Okay, so with this in mind, I'm going to move counting the agency type. Let me see. I believe this is Iran. I don't know what KP is. I'm going to FCT lump. You almost always want to lump if you have this many options. So for example, I could say, let me see. What am I lumping? I might want to look at spaceflight by country over time. So here we go. Good. Launches actually does have a state code. So I could have said count state code. So one thing to notice is that launches is actually has some data already joined in from agencies. This is not perfectly tidy data. It's not, another phrase would be, it's not normalized. We don't have only one column and one source of truth. But it does make it quite convenient if we just want to do some counts. Here we can see that, all right, state code is, right now we have Soviet Union, US, Russia. I'm going to do some recoding. What I'm going to say is, in fact, some collapsing. I'm going to use, say, state code cleaned is FCT collapse, where I'm going to, FCT collapse is a useful function in forecasts for taking, for grouping together multiple items. So I'm going to, for example, I want to say Soviet, I'm thinking for a moment how I'm going to do this. Okay. I want to turn things into country names instead of being country codes. It's one of the first steps that I want. Okay, I'm going to do this slightly differently. I'm going to do library country code. This is our data cleaning step. I'm going to say country name equals country code. There's a function that will change state code to a I actually am gonna reverse myself. Wow, I'm taking my time here. First thing I want to do is combine together Russia and the Soviet Union. Those only are differ basically based on time. So in the end data, we're gonna have to note that we collapse them together. They are different states, but I want to combine them for this data. I'm also going to, while I'm collapsing, I'm going to say both these turn to RU. While I'm collapsing, I want to change F to become FR. I want to change Japan to become, I believe it's JP. Oh, the first argument needs to be state code. Here, what I've done is I have not, I need to count state code clean. Here we go. I've changed it to be Russia, US, China, France, Japan, India, Israel, and I don't know what I stands for when it's just I by itself. It's probably going to be lumped, so it doesn't really matter. It's not going to really matter, but I'm just curious, so I'm going to say, what is I? Italy looks like. All right. I think Italy might be IT, the two letter country code. Again, I'm going to be lumping them. Italy country code IT. Okay. I'm going to rename it just while we're renaming things. All right. So I've done this step. Now what I can do is say, instead of counting, I'm going to say country name. Or let's call it state name, since that's how they describe it. They're not always countries. And I'm going to use the country code function to say state code cleaned with moving, I believe it's ISO 2C to country.name. Here we go. And what we end up with is we can then say we have Russia, United States, China, Japan, India, etc. So this fills in all the data except for our states that are not a country. So I'm gonna fix that partly by, because these are fairly rare, I can say state name equals FCT lump. We're gonna lump within the state. I'm gonna create it as a new. I'm actually going to just replace it. I'm not going to use the state name for anything else. So I'm going to lump into all but the top 6. Okay. Russia, United States, China, France, Japan, India. The trouble I have is that I really want the NAs to end up as other. I wonder what I can do if there's an option in FCT lump. Nope. I was hoping that I could say let the others, let NAs be turned into other. I'm going to use the replace NA step. It's not worth the effort of further cleaning. I say replace NA. See, state name. List state name. Other. Oh, I'm going to do that after. I can do that after. Okay. So I brought the missing ones into the other category. That's honestly, that's fine. Last thing I can see is that actually UK really should have been matched, but it looks like that's not the ISO 2C designation. That's okay. It still fits within other. It's pretty small. Again, it's not worth focusing completely on this. All right, so I'm going to call this launches processed, because we're going to be looking at we're going to be using this data in the future when we want to, for example. What I've been working towards. I've been working towards looking at launch year and state name so that I can make a graph. I can say launch year n color equals state name. This is a solid graph in terms of understanding. We can see that a lot of that peak that looked like it happened from the 70s to the early 90s, a huge amount of that peak was the Soviet Union / Russia. We could rename this to Russia / Soviet Union. I don't think it's quite worth it. I'm going to clean this up. I'm going to say X is year, why I said time before. I'm going to say launches per year. Color is responsible state. And then we could say title, launches per year per country, per state. I'm going to call it country. I think it's a little more understandable. And then I'm going to say combines Russia pre-1990 with Soviet Union with Russia. Okay, what does this tell us? It tells that a lot of the peak was due to Russia, that the United States did a huge amount of investment in the 60s during really what we'd call the space race, less so since, and that more recently we've seen China catch up in terms of number of launches, and that France, France has been pretty steady since around 1990. Okay, Japan and other have been considerably smaller. Whenever I have a graph like this, notice these countries are in alphabetical order. That's not very helpful. I like to reorder my state name. So I'd say state name equals FCP reorder. I'm going to reorder the let me see, what is it? State name by the sum of n, which means I want to put negative n. I want these to be in a similar order if you're reading from top to bottom. So notice Russia, United States are on top here, and now they're on top in the legend. Makes it a little easier to follow your way through the legend. Followed by China, France, Japan, India, other. All right, so this helps communicate a little bit. You could make the argument in a graph like this. This is one too many colors, and that we might have wanted to lump together into just 5. I think both are defensible. This might be a slightly better graph. I don't know. This doesn't put other on the bottom, and I kind of like the other to be smaller than any individual category. So I'm going to leave India in the graph. Okay. So this is understanding launches over time. I have not saved my RMD yet. I think I'm about 20 minutes in. Okay. Let's move on. I'm looking at I'm interested in what other columns there are. I've been looking mostly at agency type and the responsible state. Agency is going to be, in my view, a little too narrow. It's like we have a few too many agencies. And it's not necessarily interesting to us which Russian agency is the one that's performing the launches. Is it NASA? Is it U.S. Air Force? I think it might be a little too detailed. I'm curious about longitude and latitude because I love making maps. So I wonder if I'm not going to look at agency. Do launches have longitudes and latitudes? Nope, that's too bad. That would have been really fun. I wonder, do they have, are types really common? Nope. Okay. And what is a category? Either O or F. Don't know what to make of that. I don't have more to learn about that. Maybe I will be taking a look at agency. Let me see what else data we have in agencies. I wonder, do we ever have longitude and latitude? Nope, never. Okay. We have parent if I want to aggregate. Okay, that actually helps a little bit. I can at some levels aggregate. Oh, I've got an idea of what to look at first. Let's say we were interested only in private and startups. Let's say that was what I want to take a look at. On private and startup launches. Okay. If I look at filter agency type in private startup, we have about 1,000 launches, just under 1,000. If I counted the agency, yeah, there's we'd probably want to, I want to use, all right, so this is where I start cleaning the names of private agencies. So I'm going to start by looking at the agency data, and take a look at those names. Are all these names reasonable? Yeah, I'm most worried about, this is a very long name, so is this. Short name is pretty solid, because look at short name. We've got, all right, as long as we have a bit of understanding, like we know LMA stands for Lockheed Martin Astronautics, then short name is probably enough for us. Okay, so I'm going to take a look at, let's see, I'm going to take our launches, filter it, inner join with agencies by agency. We're going to have a lot of duplicated columns here, your .x and your .y. Like agency type, you've got these columns that pop up in both of state code. We've got these columns that pop up in both. I don't love that. So maybe what I do sometimes is do an inner join with only a few columns selected. I definitely need agency. I want name. I want short name. I don't know that anything else in the agencies table. We have a location. Oh, parent could be useful. All right, I'm just going to look at parent. So notice what I'm looking at here is we've added a couple of columns, name, short name, and parent, but nothing else. And why am I doing that? I'm doing that so that I can now mutate. I can now I can lump agencies. I can say I could start just by counting agency, but I don't want to count agency. I want to count agency name. Speaking of which, I can give a quick rename back up in this select agency name. And I know that when I do this, I probably want to do some lumping. I could say mutate agency name equals FCT lump agency name top 6 and other, maybe. Oops, I need to do this before this step. And now we have, unfortunately, we have a very common other category. That's one of the problems we're going to run into here. Is we have so many individual little agencies that have relatively few. This is very different than countries. We had a few countries that had loads of launches, and here we have far fewer. One thing I'm interested in is there some ways of categorizing these together? Okay, an example of where we might want to categorize them together is, notice Sea Launch Limited Partnership has two separate, I'm going to guess these are the same name. Okay, I'm going to look at it a bit differently. I'm going to not lump it, and I'm going to count the names. All right, we have 24 agencies. All right, do any of these naturally link together? I'm not seeing it. Okay. Okay, I'm also going to include state name. No, that means I need to do launch is processed. Maybe we can do other US, other Japan, etc. Let me see. Yeah, so the challenge here is, how can I get a graph that understands what recent activity has been done per agency, and have it like be representative, really give some information, and not just lump everything useful into an quote other category. Okay, I can see. I can see other. Yeah, here's perhaps a way to do it. I can add agency name lumped. Here's what I'm going to call this. I'm going to call this agency name lump, and we can see that everything here ends up being other, but I might want to actually say other US and link all the other US ones together. And then let's say other, maybe other Japan? Yeah, maybe other Japan. All right, so we can say, maybe not. So we could say, for example, after this step, I want to say agency name lumped is if agency name lumped is other, and state name equals United States, then other US, otherwise just other. Now we've broken it down. Oops, I Oh, otherwise, pardon me, just agency named lumped. This is a problem of combining factors and character vectors. Yep, I can't. It's a little bit frustrating. I had turned it into a factor, and now I need to turn it back into a character before I use it in this step. Okay, so here we can see other US and other. All right, so I think Japan would probably not be worth including since it has a total of 34. Okay, so yeah, so I'm going to take a look at so that's some data cleaning. So I'm going to call this private startup launches. Oh, I just realized I can separate other private from other startup. I didn't even think about that. Before I do any saving, I'm going to say, let's add, notice I keep doing this counting. I always want to look at what the most common categories are, and so that I know how to clean them. Agency type. All right, so we can separate. No, I'm not going to do this because there's only 2 startups in the entire data set. This looks like ER Systems and SpaceX. So it wouldn't make sense to say other startup. It wouldn't be, I'm sorry, Rocket Lab USA and SpaceX. Because when it's not going to, it just won't be included. All right, so now I've got, now I'm going to call this private startup launches. And I can make some graphs. I can count the agency named lumped. And I can use, I make a whole lot of these where I say, let's graph your agency name with n. Let's make it a bar plot, chord flip. And I have to quickly reorder this. Say FCT reorder by n. Should it have been a short name? Probably should have been a short name. It doesn't really need to be a short name at this point. And I can then say number of launches overall. And I'd call this the most active private startup agencies. So when I say over, so we have Arianespace leading the group, and we have other US, and then we have other. One thing I wonder is understanding countries is kind of nice, and I could communicate it through color. All right, I'm going to try something. I'm going to try saying, I know how I would say this. I could try saying fill equals state name. And say, I now need the reorder to happen within groups because I'm going to be separating state name. All right, that's actually pretty solid. What it shows is that we have France leading the group with this this category. Then we have other. Now we don't really need to separate other US from other now that we're using color to represent it. But we might in the next stage. So I'm not going to collapse these. Then we have Russia, and then a number of private U.S. Agencies. All right. So the so most active. Yeah. So what? Sometimes I like putting this as a question. Have had the most launches. So sometimes I like to show my data, show my titles as a question. This is a solid case for doing so. I'm also going to say fill responsible state. I'll call it country. It's real in here. It's country. Okay. Now that I've that's one way of saying the most common, but I might also be interested in changes over time. So I'm going to try counting this alongside launch year, and we can say launch year color equals agency named lumped N is the y-axis. When we have a graph like this, we need to realize that we probably do not want it per year. There's way too much noise. We'd probably rather have it by decade. So we can say decade. I've done this step a lot. I say 10 times launch year over 10. And look by decade. Okay. When you have a graph like this, it's sometimes nice to have 0 be represented. So check this. So notice that like this line appears out of nowhere. It doesn't appear out of nowhere. It should go back. It should go down to 0 for the following decade. So what I can do is say complete. I want every combination of agency name and decade to be included in the data in this complete step. And then I say fill n with number 0. Now we have a bit more of a. Yeah, now we can see a bit more of the data. And now I realize I don't necessarily want to divide it by decade. What if I grouped it by every 5 years? Ah, what a noisy plot. Too much going on. Too much going on. There is too much going on, but it does get a lot of across. What it's basically trying to show, let me see. All right, what I'm trying to show here, what I'm trying to see here, actually, I think it's going to be a little better if what I do is, if I do that sort that I did before. If I say I want the ones I want to, when I say before, I mean on countries. Here it is. I'm going to apply this reordering where I say reorder your agency name lumped. Now I can read down the list a little bit, like here's area and space first. Still too many lines. Oh, when you have too many lines, it's probably a good idea to facet wrap instead of using color. And while we're at it, I think here we go. Yeah, this actually gets it across quite a bit better. One of the problems we run into is some of the names are too long. I'm not going to clean this right now, but the thing to do would probably be to to use short names when the name is too long. So here we're seeing launches over time, and we can see other private areas in the agencies in the U.S. besides the ones listed here, like Lockheed Martin, have been pretty rare. SpaceX is showing a real increase in the last couple of years in terms of number of launches, and some others like McDonnell Douglas Space Systems Corporation have been decreasing. So we generally get a sense here of what the change has been. And notice, I can now remove the legend. So it says legend position equals none. Probably want that last. And then I can say X is time, Y is number of launches in 5-year period. Yeah, this mostly gets it across. Okay, all right, that's interesting. I also might be interested in types of shuttles. So let's see let's look back at the launches data. We have type and variant. I wonder if I count type and variant. We have Soyuz. I know that's a Russian model. Many of these are. And I don't see, where's the variant data? So we can probably ignore variant. It's probably particularly specific to certain shuttles. All right, so I've got a neat idea for this. If we were like if we were space enthusiasts, we were interested in understanding the evolution of types of spacecraft used. This would be some solid data in terms of making timelines. We could say, let's group by type, and we could say we could summarize into first launch is min of launch date I'm going to use launch year, last launch, max of launch year. We could have used date. I think it's probably not useful for the kind of timeline we're creating. And we could also say launches equals, anytime we do an application, we want to know the number of launches. In fact, we can probably arrange in descending order of the number of launches. Okay, so here's a type. I'm going to throw in this, I'm going to make this on launches processed, and I'm going to throw in the state name. So I'm going to say, and anytime I group by two things, I want to add it. Why have I added this in? Because I want to have the understanding that these first 5 items are Russian craft, and this next one is U.S., and then we keep seeing more Russian craft. There's so many points that are types that are Russia, that is either Russia or Soviet Union, that it's probably worth it's probably worth a graph of its own. Yeah, we can see so many of these commonly used prolific shuttles are Russia. Okay, so we would basically call this history of Russian rocketry. Would be the way we could frame this. So for this next visualization. So I'm going to call this by type. It's by the type of the craft. And here we go. Type of launch vehicle. The type of so each of these is a vehicle. I could actually call this vehicles, because that's what we're aggregating. Okay, so then if I took vehicles, and I filter for Russia, also Soviet Union, we have 64, that's way too many. Descending launches. I could start with those that have at least 100 launches. Okay, so we could say filter launches greater than or equal to 100. We end up with 9. What am I doing with this? I'm saying Russian vehicles. I wonder how many would hit 50. This might still be reasonable. Okay, I'm going to show what kind of graph I'm making. I want to make a timeline. I want to understand how Russia changed from one type of shuttle to another. So we're going to take a look at, here we go, launches processed. And we're going to inner join with the Russian vehicles. That is with the aggregated data by type. And state names. We can actually semi-join, and it'll be pretty reasonable. We want to say take only the rows that were one of these vehicles with at least 50 launches. All right, why am I semi-joining? Because I can make a visualization that is on the x-axis, put time, launch date. On the y-axis, put the type, the rocket. And then throw in a point for every single launch. All right, we discover some bad data. We have a launch date that is 1,000 years in the future. So we probably want to, when we do launches processed, we should filter for launch date is less than or equal to today. That's not crazy. I need to do that in the step where we define launches processed. And if I now visualize it, good, much better. All right, so now we're actually building a timeline. But notice we don't really want it, this is right now in an arbitrary, it's in fact alphabetical order going this direction. That means we want to say mutate type is reorder your type by, I'm going to say your average launch date. Can you do average launch? Yeah, I guess you can. Great. By your launch date. So we can see it's pretty clean in terms of when something goes into commission and is taken out. I used mean. I used the middle. I think it might make sense to use min. Like when was its first launch? All right, I like this graph way more. I like to say like here's where Russia started using. This is very early in the space program. Where they started using regularly, and here's what they're using. This looks like up till today. Okay, that's for every shuttle that had at least 50. What if I changed it to 30? Would there be a lot more data? There'd be a little more. Okay, I'm going to use it that way. One thing I notice is there's like a model that fits in these. Like you have Soyuz, I don't know how to pronounce these Russian terms, but Cosmos, Cyclone, maybe, Vostok. I wonder if we could use those as like colors. Might make sense. Maybe it's not that, it might not be that important. I also wonder, within our Russian launches by these particular vehicles, if I counted the agency. No, most of them look like they're missing an agency. That's a little strange to me, since that's what we're using to combine with other data. Is that the case that if I looked at just our raw launches data, and I said, is NA agency? Well, yeah, it looks like a bunch of them are missing an agency. Okay, I guess we just know that it's Russia. Okay, so I probably shouldn't go any deeper into like dividing between agencies. I wonder if I counted category, what it means. I still don't know what F and O mean. All right. All right. So what could I'm just thinking, what else can I communicate in this kind of timeline? I also wonder, like, is dots the appropriate metric? Because I could use a ridge plot. I could use... Dots are kind of right here, because what we're really communicating is a timeline. We want to say these are the years where it was actively used. So at some level, I might want to say, oh, this model really was cut off here. And if I just... let me explain what the alternative I'm considering. We could have taken this plot. We could have said, instead, I want a type and launch date, and I want a box plot. And I want to coord flip it. And it would have looked more like this. The reason I don't love box plots over time, this does get the impression, I see, most of them were in this range. This is when it was most active. It communicates more information, but I'm not sure it's a better graph. Because it's not really a distribution of, it's not really a distribution. It would show where it was most actively used, but you can't really look at quantiles in this way. Okay, so I'm going to instead try jitter. So I'm going to say is geom. I think I can say geom jitter with. I do not want any horizontal jitter. I want a little bit of there's too much of vertical jitter. And heck, while I'm at it, I can say make the points transparent. All right, what this would communicate is the Soyuz this was used really heavily and was used in this particular period of time, and then we can see the density really kind of breaks off, and then here's 1 point out here. Okay, I can even probably make the points a little more transparent. Maybe it is too transparent. It's hard to say. But this shows like what shuttles were most actively, what vehicles were most actively used during this type. So we could say timeline of Soviet/Russian space vehicles. And we could say on the y-axis launch date. Notice I originally aggregated to find these ranges, but I realized I don't need them as if I'm making a timeline, I could have used that. I don't really need this that for this data. I don't need the first launch, last launch. In another visualization, we could have used that. So here's. I am doing this incorrectly. I need to put this here and say X is launch. I'm not going to use the box plot. X is launch date. Y is vehicle type. And we have to add the subtitle. I like to add the clarification, only vehicles with at least 30 launches. Otherwise, we included too many that had very few. Okay. This is definitely one way to visualize it. And we can see the kind of like change over time. Speaking of changing over time, one thing we can try if we want to make this a little more visually appealing, I don't know that it's necessarily very informative, but we could say, as a fill, use the type and drop the legend. What is this going to do? It's going to turn this into a bit of a rainbow. It's going to say, I used fill, I meant to use color. I think it's a little more visually appealing. Maybe it doesn't make a difference to you, but it's like it goes from red in the early days, yellow, green, blue, modern times, pink. Well, a downside of using this is it might make it harder to compare between early shuttles and later shuttles. So because since we are using like density as a metric for visualization, so I'm not going to use that in this graph. To make it a little more appealing, I'm going to try, space is kind of blue. I'm going to try just making them all blue. All right, I like this version. Okay, so here's Soviet and Russian space vehicles, and I'm going to look. Now that I realize how I'm visualizing this, that I'm not using the aggregated data, I could create one for the U.S. as well. I'm gonna do it slightly differently. I'm going to filter for state name equals is the U.S. I'm going to add count, and that's a verb dplyr that's going to add a column based on the number of each vehicle type. Oh, state. Oops. State code is US. I might want to filter for only public. I'm not that sure yet. If I count type, I'm going to try using. I've got an idea of how I'm going to approach this. I am going to keep everything, but I'm going to add count for the and add count for the vehicle type. I'm going to filter for you must have at least 20 launches. And then I'm going to, instead of setting a fixed color, I'm going to say color equals agency type. So for example, this will separate the private and the public. Aha! I like this visualization. What is this showing? This is showing the time period of. I need to put my legend back. Here's your state launches. Here's your private. Here's your startup. So startup, I'm going to guess, is almost entirely SpaceX, since we did see that was the majority of the SpaceX of the private launches in the data set, the startup launches in the data set. So each of these are probably other types of agencies. And we can see periods of time where each of these shuttle types are used. I'm going to try including a little more data. Whenever I make a graph like this, I like to really crowd in as much. Crowd is a stretch, but I like to say how much data can I bring in here? How informative can I be? You know what's amazing is, where is Saturn V? Does Saturn V really have fewer than 15 launches? Filter, string detect, type. Because I believe we saw that Saturn V was what the Apollo vehicles were. Yeah, Saturn V had 13 launches. I really want it to be included in the data, so I'm going to hack this slightly and include it. That might have been a less than amazing choice. It's very hard to read through all of these. Okay, then I'm going to go ahead and change back to 20. Timeline of U.S. space vehicles. Only vehicles with at least 20 launches. And it's worth noting that therefore removes a lot of important space missions in, say, American history that might have had very important launches but didn't have very many. So we're mostly seeing Thor, Atlas, Titan. This tells me, we're seeing versions of each of these over time. So we see like whatever Thor and Atlas were, they're not really used since then. And we have the space shuttle, a really notable U.S. Space accomplishment that was used very actively between 1980 and 2010. Okay, so then we could really see that this really shows kind of the shift to private, similar to the other graph we showed earlier, but it shows the updates of models within the private sector as well. And then here we have a shift to the latest player in terms of a space vehicle, Falcon 9, by it looks like SpaceX. Okay, so the final what I'm going to be taking a look at is what I'm going to be cleaning up in this graph is I want to say color equals agency. I'm going to say agency, yeah. Agency type, space, and this is maybe our final. I'm going to take agency type and also string to title it. I'm really trying to clean this up, be as presentable a visualization as I can make it. This is my timeline of U.S. space vehicles. So here's how they were launched over time, how they shifted from state to private to startup. Okay. So that's the time we have. Let's review what we examined. A lot of what I was looking at, I need to clean some data, but mostly looked at how we shifted from state to private to startup. I looked at how we cleaned some country data and looked at the change in launches per year per country, and combining Soviet Union and Russia, and also combining private and startup and state launches. We took a look at what private agencies have had launches. We saw some of the most common ones, and then we saw how they've changed over time with a faceted graph. And finally, we took a look at the timeline of vehicles in both Russia and the United States. All right, so that's the time we have. I hope you had a good time. I hope you found this topic as exciting as I did, and I'll see you next week.